Hello students, today we will learn about enthalpy of solution, lattice enthalpy and Born-Haber cycle to calculate lattice enthalpy of sodium chloride. So let us begin with enthalpy of solution. Enthalpy of solution is denoted by delta H naught solution. It is enthalpy of solution of a substance is enthalpy change when 1 mole of the substance dissolves in specified amount of solvent. Say for example 100 gram of solvent. Say if we take 1 mole of sodium chloride, it means that is atomic mass of sodium is 23, chlorine is approximately 35.5, so that we get here 58.5 gram. So if we take 58.5 gram and dissolve it in 100 gram of water or 100 ml of water, then whatever the enthalpy change we observe, that is called as enthalpy of solution of sodium chloride. Actually what happens is, if we take sodium chloride, in reality if we observe the structure around the, that is at the corner of each of the corner of a cube, the chloride ions will occupy, and also at each face center of the cube, the chloride ions will occupy. This is a real structure of sodium chloride, and in between that the sodium ions occupy. That is, each sodium ion is surrounded by chloride ions and each chloride ion is surrounded by sodium ions. Sodium ions in nanu dark green in the parrot green color in the torsidini, and the chloride ions, as they are bigger in size, they are shown with pink color. Okay, this is real structure and they are held by electrostatic force of attraction. If at all we add it to water, in a container having a water, what happens is these bonds, they break and sodium ions and chloride ions, they set free, and the water molecules surround in such a way that oxygen end, it faces the sodium ion which carries a negative charge, and hydrogen end carrying a positive charge, it surrounds the each of the chloride ion. So ee tara agutte. So what happens is, actually the bond breaks. So the bond breaks between the sodium and chloride ions, and sodium and chloride ions are set free actually in the gaseous phase, and then they are surrounded by water molecules. This process is called as hydration. Okay. Now, certain amount of energy changes we observe, that is called as enthalpy of solution. See, enthalpy of solution at infinite dilution is the enthalpy change observed on dissolving the substance in infinite amount of solvent when interactions between the ions are negligible. If at all we take in a container water and if we add sodium chloride, say for example sodium chloride, sodium and chloride ions are set free and water molecules, they surround these ions, that is hydration of the ions takes place, and these ions, they do not interact. But if we add a very large amount of water, then practically in reality these ions do not react with at all. For that, whatever the enthalpy change observed, that is called as enthalpy of solution at infinite dilution. Say instead of sodium chloride, if we take AB as a solid, if we dissolve it in water, or then the hydration of the ions, sodium badlu illi A plus anta tagolthivi, B minus. The energy changes observed are called as enthalpy of solution. In reality what happens, the structure, it breaks and we are going to get the ions in the gaseous state. So whatever the energy changes observed, it is called as lattice enthalpy. These ions, they are surrounded by water molecules to get hydrated ions. This is called as hydration enthalpy. Thus we say that enthalpy of solution is equal to lattice enthalpy plus hydration enthalpy. Because when an ionic compound dissolves in a solvent, ions leave their ordered positions on the crystal lattice and move freely in the solution. But at the same time, solvation or hydration of these ions also occur. For most of the ionic compounds, standard enthalpy of solution is positive, and the dissociation process is endothermic. Thus, solubility of most of the salts in water increases with rise in temperature. If at all we observe the lattice enthalpy, if at all it is very high, then the compound dissolution of the compound may not take place at all, because say for example sodium fluoride, they are, that is sodium ion and fluoride ions, they are very strongly held together, and thus their lattice enthalpy is very high. These fluorides are less soluble compared to the corresponding chloride and bromides of the particular salts. Okay. Next one, lattice enthalpy. Lattice enthalpy of an ionic compound is the enthalpy change which occurs when 1 mole of the ionic compound dissociates into ions in the gaseous state. ಅದಕ್ಕೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡಿದ್ದೆ, sodium chloride solid. It dissociates to give sodium ions and chloride ions. ಆ ಸ್ಟ್ರಕ್ಚರ್ ನಾನು ನಿಮಗೆ ಹಾಕಿ ತೋರಿಸಿದೆ, ಹೌದಾ? ಅಲ್ಲಿ the strong electrostatic force of attraction, it breaks and the ions set free in the gaseous state. The energy supplied is called as enthalpy of lattice enthalpy, and it is equal to plus 788 kilojoules per mole. Since it is impossible, ನಮಗೆ ನೋಡಿ ಸಾಲಿಡ್ ಇಂದ ಗ್ಯಾಸ್ ಅಯಾನ್ಸ್ ಬರಬೇಕು, ಇದಕ್ಕೆ ನಾವು ಎಷ್ಟು ಎನರ್ಜಿ ಸಪ್ಲೈ ಮಾಡ್ತೀವಿ ಇದನ್ನು ಕಂಡುಹಿಡಿಯೋದು ವೆರಿ ಡಿಫಿಕಲ್ಟ್. That's why it is impossible to determine lattice enthalpies directly by the experiment. We use an indirect method where we construct an enthalpy diagram which is called as Born-Haber cycle. Now we will study in detail what is this Born-Haber cycle. Okay, so Born-Haber cycle to calculate lattice enthalpy of sodium chloride. Sodium solid combines with the chlorine gas, half mole of chlorine gas, to form 1 mole of sodium chloride. By definition, enthalpy change is nothing but the standard enthalpy of formation. It is equal to minus 411.2 kilojoules per mole. The same we can represent it as sodium solid combines with half mole of chlorine gas to form sodium chloride. The same process can be obtained, that is sodium chloride can be obtained by indirect method. That is, sodium solid can be vaporized. 1 mole is vaporized and the process is sublimation. Enthalpy change observed is standard enthalpy of sublimation, which is equal to 108.4 kilojoules per mole. This sodium gas, it gives sodium ion in the gaseous form along with liberation of an electron. By definition, what is this? There is 1 mole of isolated neutral gaseous sodium and it loses an electron to form sodium ion in the gaseous state. By definition, the enthalpy change is ionization enthalpy. It is equal to plus 496 kilojoules per mole. The chlorine gas, it gives 2 chlorine atoms. Since we are taking half mole, we get 1 chlorine atom in the gaseous state. So here what happens is chlorine bond breaks and we are going to get the chlorine atom in the gaseous state. So by definition, enthalpy change is nothing but the bond dissociation enthalpy, and it is half of this is 121 kilojoules per mole. Now there is electron released. This electron is combined with the chlorine atom in the gaseous state and we are going to get the chloride ion in the gaseous state. By definition, it is, that is, an electron is added to isolated neutral gaseous atom to form the ion in the gaseous state. It is nothing but electron gain enthalpy. It is equal to minus 348.6 kilojoules per mole. Now we have here sodium ion in the gaseous state, chloride ion in the gaseous state. both of them combine and we get the structure that is sodium chloride structure. ನಾನು ಅವಾಗ ತೆಗೆದು ತೋರಿಸಿದ್ದೆ ನಿಮಗೆ. ಈ ಥರ ಇದ್ದರೆ ದ ಕ್ಯೂಬ್ ಇದ್ದರೆ ಕ್ಯೂಬದ ಕಾರ್ನರ್ಗೆ ಕ್ಲೋರೈಡ್ ಅಯಾನ್ಸ್ ಆಕ್ಯುಪೈ as well as at the each of the face centers, and the sodium ions occupy in between the chloride ions and they are held by strong electrostatic force of attraction. It is exactly sodium chloride. It gives the sodium ion and chloride ions in the gaseous state. Exactly reverse process. So enthalpy change is nothing but minus delta H naught lattice enthalpy. So we will apply Hess law, that is sodium chloride is obtained by direct method, that is sodium and chlorine gas combine to form sodium chloride. This is one route, and the second route is the sodium to sodium ion in the gaseous state, chlorine gas to chloride ion in the gaseous state. Both of them combine to form sodium chloride. Energy changes must be one and the same. So that is what we will see now. The first process, what is it? Sublimation of sodium metal. Sodium metal sublimes to give sodium. In the gaseous form, enthalpy of sublimation is 108.4 kilojoules per mole. The second one is the sodium gaseous atom. It loses an electron and we get sodium ion. That is ionization of sodium, and ionization enthalpy is 496 kilojoules per mole. The next process is dissociation of the chlorine, and the reaction enthalpy is half the bond dissociation enthalpy, which is equal to, that is half mole of Cl2 gas gives Cl in the gaseous state, and this enthalpy changes 121 kilojoules per mole. The next one is electron is gained by the chlorine atoms. The electron gain enthalpy is minus 348.6. Cl gas plus an electron which is lost by sodium, and we get Cl minus ion in the gaseous state. The enthalpy changes minus 348.6 kilojoules per mole. These sodium ions and chloride ions, they combine to form sodium chloride, and the lattice enthalpy is how much? Idu namge direct method inda barudilla. By using Hess law, we are going to calculate it. So that's what we have shown in the above diagram. So ee diagram ನೀವು ಏನು ತೆಗಿತೀರಿ ಇದಕ್ಕೆ 1 mark will be there. Okay, sometimes ಇದಕ್ಕೆ 2 marks ಕೊಟ್ಬಿಡ್ತಾರೆ. ಸೊ ಈ ಡಯಾಗ್ರಾಮ್ ನೀವು ತೆಗಿಲಿಕ್ಕೆ ಪರ್ಫೆಕ್ಟ್ ಆಗಿ ನೆನಪಿರಬೇಕು. Okay, otherwise you will have to explain all this. This will give you 2 marks. So these sequence of steps is shown above, and this is known as Born-Haber cycle. The sum of enthalpy changes around the Born-Haber cycle should be 0. So by direct method andre sodium and chlorine, they combine to give sodium chloride. Enthalpy change is delta H naught F. This should be equal to delta H naught F should be equal to each process alli tagoltivi. One is standard enthalpy of sublimation plus standard ionization enthalpy plus half the bond enthalpy, electron gain enthalpy, and lattice enthalpy. That's what we are going to write here. Delta H naught F is equal to delta H naught sublimation, delta H naught I half the bond dissociation enthalpy, electron gain enthalpy, and minus lattice enthalpy. Therefore lattice enthalpy ನಾನು ಇದನ್ನು ಈ ಕಡೆ ತಗೊಳ್ತೀನಿ and delta H naught F ಈ ಕಡೆ ತಗೊಳ್ತೀನಿ. So delta H naught lattice enthalpy is equal to delta H naught F. ಉಳಿದದನ್ನು ಹಾಗೆ ಬರೀತೀವಿ. delta H naught sublimation and delta H naught I half delta H naught dissociation, delta H naught gain enthalpy. Values ಅನ್ನು ನಾವಿಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ. So we get the answer as 788 kilojoules per mole. ಇದನ್ನು 3 ಮಾರ್ಕ್ಸಿಗೆ ಕೇಳ್ತಾರೆ ನಿಮಗೆ. ಇದನ್ನೇನು ಬರೀತೀರಿ, this will give you 1 mark. And Born-Haber cycle, ಇದನ್ನು ನೀವು ಕರೆಕ್ಟಾಗಿ along with the values, if you write it, this will be for 2 marks. ಇದು ನಿಮಗೆ ಬರೀಲಿಕ್ಕೆ ಅಕಸ್ಮಾತ್ ಆಗಲಿಲ್ಲ ಆವಾಗ ಈ ಸ್ಟೆಪ್ಸನ್ನು ನೀವು ಮೆನ್ಷನ್ ಮಾಡಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀರಿ. that will give you 2 marks. Okay, now consider if at all we take sodium chloride, it gives sodium ion and chloride ions. So what is the internal energy change? So we know that delta H is equal to delta U plus NR delta Ng into RT ಅಂತ ಬರೀತೀವಿ. What is this delta Ng? The number of moles of products in the gaseous form, that is 1 plus 1 ಅಂದರೆ 2, reactant ಅಲ್ಲಿ 0. So 2 ಅಂದರೆ ಇದೆಷ್ಟಾಯಿತು, delta Ng is equal to 2, and this is by one of the method it is calculated as 783 kilojoules, but by actual literature method we get it more accurately as minus 784 kilojoules per mole. So for 1 mole of sodium chloride, delta H naught of hydration enthalpy, ನಮ್ಗೆ ಗೊತ್ತಿದೆ enthalpy of solution is equal to lattice enthalpy plus hydration enthalpy. ಈ hydration enthalpy ಎಷ್ಟು ಬರಬೇಕು? ಇದು by accurate method it is 784, not 783. ಅದನ್ನೇ ನಾವಿಲ್ಲಿ enthalpy of solutionಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ this will be 4 kilojoules per mole. ಇದರ ಅರ್ಥ ಏನು? If we take 1 mole of sodium chloride, ಅಂದರೆ 58.5 gram of sodium chloride, it is dissolved in the water. Say for example 100 gram of water, it requires 4 kilojoules of heat to dissociate. ಅದು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಕರಗಲಿಕ್ಕೆ 4 kilojoules ಹೀಟನ್ನು ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಳ್ತಿದೆ. ದಿಸ್ ಇಸ್ ವೆರಿ ಲಿಟಲ್ ಹೀಟ್ ಚೇಂಜ್. ಅದಕ್ಕೆ ನಾವೇನು ನೋಡ್ತೀವಿ, ಉಪ್ಪನ್ನು ನೀರಿಗೆ ಹಾಕಿದರೆ ವೆರಿ ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ಸ್ವಲ್ಪ ಅದು ತಂಪಾಗುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ದಿಸ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಶೋಸ್ ಅಸ್. ನಿಮಗೆ ಯೂಶ್ವಲಿ ಏನು ಕೇಳ್ತಾರೆ, ಎಕ್ಸ್ಪ್ಲೇನ್ ವಾರ್ನ್ ಹೇಬರ್ ಸೈಕಲ್ ಅಂತ ಕೇಳ್ತಾರೆ. ನೀವು ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು, ಈ ಸೈಕಲನ್ನು ನೀವು ಡಯಾಗ್ರಾಮ್ ತೆಗಿಬೇಕು. ನೆಕ್ಸ್ಟ್ ಈ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಬರೀಲಿಕ್ಕೆ ಬಂದರೆ ಒಳ್ಳೆಯದು, ಡಯಾಗ್ರಾಮ್ ತೆಗೆದ್ರೆ ಬರದೇ ಬರೀತೀರಿ. then you will have to show this calculation up to 788 kilojoules, ಅಥವಾ ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಮಿನಿಮಮ್ ಇಷ್ಟರು ಬರೀಲಿಕ್ಕೆ ನಿಮಗೆ ಬರಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ಬಾರ್ನ್ ಹೇಬರ್ cycle.